we're going to take a look at problem 2e. So problem 2e says, if k of x is defined by this, what is the value of k prime of 3? So based on the comment of one of your classmates, she said her question was like, how do I apply the rules, multiple rules at the same time? So what she from if you're looking at this from like a new perspective, right, as in just seeing for the first time, it's a little confusing because you have a couple of things that's going on, right? It's not as simple or clearly related to the particle because it's not written as like k of x equals 2 times f of x times g of x. Or we have some extra terms. We have this added 3 and this 3 minus, and the how do we actually deal with that scenario? So the strategy in approaching this problem is to kind of look at it from like a broader perspective in terms of like what's the main rule is how your classmate suggested have phrased it, right? She recognized that it was a product rule, and what she saw was that she looked at this whole chunk here is called, she saw it as like the f of x, right? And then this was the g of x. So if we take that perspective, then we see that, in general, the main rule is the product rule, right? This function multiplied by this. So that's a really good insight in terms of trying to like start this problem, is to recognize that, I have to use the product rule. Now, within the product rule, I'm going to have to use the other rules that I've learned. And although having a plan is great, and now it's like, the question is like, well, how do I do those at the same time? The strategy is not to apply different rules at the same time, right? You can't multitask when you're taking derivatives. You have to apply the main rule, and as you carry out the main rule, you might have to do a derivative step in there which will require some other rules, like the constant multiple rule. So before I get into this as well, the like the actual product rule, um, some people might have a question about like is this f of x and this f of x is the same? The answer is no, right? These two are not the same, right? But you're trying to take the broader perspective that this is gonna stand for the f of x that's in the product rule, and this is gonna stand for g of x in the product rule. So I showed this to you guys so because this helps with like not being hung up on the actual label and wondering if they're the same or not. Is I try to think about in the functions and in terms of like their position, meaning where they are in terms of the equation. So since this whole chunk comes before this chunk here, I think of it as like this is the first function. So I think of it as the first function, and I use f, and then I think of the blue function as the second function because it comes second, right? So when I think in terms of position, it makes it a lot easier for me to look at instead of being hung up on the labels itself. So we can modify the product rule as this. So first times the derivative of the second, right? S is the g of x, f of x is the f, is equal to first times the derivative of the second plus the second times the derivative of the first, right? So that's another kind of helpful way that I try to remember without being hung up on the labels itself. Okay, so whether you prefer this one or you prefer this one, the essential thing is that we gotta make sure we have the right rules and that we kind of take our time to carry out the rule accurately. And as we do it out, we might have to use other rules. So I'll model it for this one so you guys have an example, and you're gonna run to this in the problems that come after as well. So okay, so first function is this. So since I just say first, that means I'm going just to copy it down. So first function times the second derivative of the second function. So now I have to look at I need to find the derivative of the second function. This is where we're going to have to apply other rules. So the derivative of 3 using constant multiple is going to be 0, and the derivative of g of x is going to be g prime of x plus the second. So since I just said second, not the derivative of the second, I'm just going to copy down the second times the derivative of the first. So now I'm looking at this as my first. I need the derivative. Now I'm going to have to apply the constant multiple rule for this, and that's going to give me 2f prime of x plus the derivative of 3 is 0. Okay. So I just carried out the product rule, um, and that's the derivative of the original function k of x. So I suggest you guys like kind of go back and watch that how I wrote that out in the reasoning and kind of apply it for yourself. And I'll leave you guys to actually find the k prime of 3.